2, section B, MYE, paper of science, P4, and question number 31. Life cycle of an insect. When it's an egg, its laid is 5 days. It remains for 5 days before it becomes a nymph. Okay, and remains as a nymph for 12 days before it becomes an adult. Right? It lives for 8 days when it's an adult. So how many stages are there in life cycle? The life cycle of insect X. It is insect X has a three-stage life cycle. Okay, 1, 2, 3. Now next, how many days would insect X take to become an adult after the egg is laid? Look, the egg is laid here. The egg laid here, and it has 5 days as an egg, and another 12 days as a nymph before it becomes an adult. So 5 plus 12, 17 days. Okay, right? The insect will take 17 days before it becomes an adult after the egg is being laid. Next, name an insect that has different number of stages in its life cycle of insect X. Insect X has 3 stages. The insect you name, any insect with 4 stages will do. For example, mosquito, butterfly, moth, beetle, and housefly. Okay, let's go on next. Okay, these two are the larvae of the, this is mosquito, this is insect water, and this is the butterfly. Okay, right. Now, do get yourself very familiar with the life cycle of these insects. For example, the mosquito, where they are in the water, pupa, how does it look like? Okay, and what does it do when it's a larva? Does it eat a lot, and do they molt, and so on and so on? These are the facts you must know, okay, for at least these two type of insect. Now, state a similarity between the larval stage of these two insects. Both of them molt. Okay, they don't look like their parents. You may have this answer. B, C, they cannot fly compared to their adults, and they eat a lot or move a lot. Okay, right? So these are the 4 possible answers. At which stage of the life cycle do they have the characteristics of an insect? It means insect you must know, okay? To tell somebody that, okay, look, this animal is an insect, you must have identify certain things, okay? Let's take first, to qualify as an insect, you must have 3 body parts, okay? 3 body parts. What are the other one? Okay, very important. 6 legs. 6 legs. Okay, these 2 main ones. Alright. Any animals with 3 body parts and 6 legs, they are qualified as insect. Only in the adult stage. Only in the adult stage you can see this physical characteristic. You can see the legs, you can see the body parts. Not when they are mosquitoes, not when they are an egg or pupa. Right? That is what you should understand. Okay, next. What would happen to the life cycle of these insects if they are eaten up by other animals in the stage? So, to the life cycle, the key is to the life cycle, not to the insect. All right? Of course, the insect dies and so on. But the cycle, what will happen? Okay, so their life cycle cannot continue, right? One of the answers. Or you may write, their life cycle would stop, or cannot resume, or cannot repeat, or cannot reproduce, and cannot turn into the adult, and so on. Alright? Something that breaks off the life cycle. Right? If you say the insect dies, it is not correct. Right? Okay, number 33, David conducted an experiment by placing some seed in a tray. Okay, these seed, okay, all with damp cotton wool, it means this 4 C's over here, part Y, they are wet, okay? Part X, they are wet because they are placed in damp cotton wool, okay? Now, the part X is covered with cardboard, okay? All right, of course, air flows inside. Both this part Y and X, they do have air, they do have water. Over here, they have more of light. This one will have less of light, okay? More or less covered and it's darker. All right, let us see from here. David was trying, what was he trying to find out? Was he trying to find out if the seeds need sunlight to grow? Okay, now all you have to do is wait a while. This without much light, this is with sunlight, and see whether they germinate, okay? True, okay? So, but of course you need to know both sides will still germinate, even being shaded in part X, okay? Even here it will germinate and here will germinate, all right? Now, seeds from both part X and Y will germinate, true. And next, see, in order to make the experiment a fair test, David must use the same type of seed. Yes, of course. Now, if you use different type of seeds, for example, here, then you see the seed grows faster, and this seed over here might not grow fast, might not germinate fast, okay? Might take a longer time to germinate, and you may think that because it's shaded, it will not germinate, all right? So it has got to be the same type for a fair test. Let's continue. Number 34, the growth of a young plant was measured over a period of time and recorded in a graph. So over here, this part X, okay, the height, okay, remains at 0, no growth, nothing, no activity, all right? But that does not mean it is not alive, okay? Just that the physical part, there is no growth in height, all right? No change. And over here, it starts growing, growing, and growing, taller and taller. As time goes by, it grows taller and taller, according to this graph. Now, how does this graph prove that the young plant is a living thing? Okay? Over here, you can't really prove that it is a living thing because there's no movement, no physical proof, all right, to show that there is growth. Now, please remember, as a living thing, they have this. They need to do. They can do these things, right? These 4 things. They can grow, they can reproduce, they can move by themselves, and they can respond to changes, all right, around them. Now, so this is one of the points. It says it grows. Okay, so the plant grew in height, okay, or grew taller to show that it is a living thing. All right. Next, why does the seed remain at 0 cm over here? Okay, for the short period of time. So just ask here. All right. Now the answer is the seed has not germinated. It means the seed remains as it is. All right, as it is. It doesn't grow out, okay, to allow you to see the seedling, all right, which is growing with the height growing. Now, it is still absorbing water to get germination started. Now, there are no growth activity within, but we cannot see that, okay? Oh, sorry, there are growth activity within. It means within the seed itself. It's just that we just cannot see the shoot coming out. Right, it is just developing, getting the roots and the shoots coming out, okay, and probably within the seed it does not grow much. It remains 0 until the roots and the shoots sprout out. Now fill in the blanks with the terms seed and seedling. Now this is straightforward, self-explanatory, seed and seedling. Let's continue. So look at this. These are metals, all right. 3 kilogram. Watch the weight. They are the same. 3 kilogram, 3 kilogram, 3 kilogram. Okay. Now, of course, cotton wool will look large. You need to have more of them, okay, to ensure that the weight of this is the same as this. All right. Now, over here, cotton wool is the lightest. No, it's totally false. what you need to do to find the weight of any matter here, you compare. Okay, so long the weight are the same, you just cannot say that any one of them is heavier or lighter. Alright, so these matter here, they are of the same weight. If you say cotton wool is the lightest, we are wrong. Okay, next, the three objects have the same mass, correct. Alright, and the cotton wool has a greater volume than the paper. Okay, it simply means, right, greater volume, can you see? Okay, it occupies more space. Of course, you do not squeeze it, do not squeeze it into a smaller box also. Just as it is, it occupies more space than the paper here. Alright, although they have the same weight, but the volume is different, the size is different. Let's carry on. Now Tom placed two substances, X and Y, into a beaker. Now this is, the arrow here means this is before, this is after. Okay, so first one, substance X over here, you tilt it, and after that the shape still remains the same. But for this substance Y, you tilt, right, it from the beaker, the water level or the the shape change, right? Most likely this is definitely liquid, right? The liquid has the water level, okay, got to change, and the water level most probably is definitely parallel to, okay, you see very carefully, water level, you tilt it, it will still continue to be parallel, okay, parallel to here, okay, parallel to the table, all right, over here, all right, okay, let's carry on. So which one, let's take a look at the question. Substance X is solid state. What is the state? Remember, when they ask for state, solid state, liquid state, or gaseous state. So solid state, this, okay, substance X is solid state because it has a definite shape, it does not change its shape. Next, what is the state of substance Y? Liquid, okay, right, liquid state. Next, if we place substance X in a bigger beaker, now substance X is solid, we place it even in a different container, a bigger container, what will happen to the shape? All right, and we know that solid has definite shape. You don't mess up with it, it will not change the shape. By just placing it to a bigger beaker, the shape will still remain the same. Right? Next. Number 37, Mark conducted an experiment with substance Z. Take a look. Note here, substance Z is inside here and inside here. Obviously, you see there's it's not liquid, must be gas. Okay, and when you push the plunger in, this is before, this is after or during experiment. Okay, you push the plunger in, it compressed. Okay, what can be compressed must be a gas. Okay, a gas has no definite volume, no definite shape. Look at that. The size changed this way, okay, to smaller size, and the shape from a longer rectangle into a shorter rectangle. Okay, now based on the picture above, what was the aim of Mark's experiment? He was trying to find out if substance Z can be compressed. Okay, this is one of the answers. Or if substance Z has a definite volume. Right? By pressing it, it shows that it has no definite volume. So we just want to find out. Alright? And it managed to find out that the volume changes, the size changed. Based on the experiment above, what can be concluded about substance Z? We can conclude that substance Z can be compressed. Substance Z has no definite volume. Alright? Now, based on the above results, what is the state of substance Z? Gaseous state. Okay? Next, is substance Z a matter? Of course, yes, it is a matter. Even gas, liquid, solid, and this is gas. Okay? It is a matter. Why? All right, straight away say it has mass and it occupies space. Right? Gas is a matter, it has mass, it occupies space. Now this is a cycle over here, and of course it goes up and comes down as water. Now let's take a look. They say, yes, this is a cycle. Do you agree with Matthew? Yes, this is a cycle, but this is not a life cycle. Okay, Matthew says this is a life cycle. I would not agree because it's not a life cycle. All right, it's just a cycle of the water going, all right, round and round. Now, using the objects, okay, they just mentioned that these over here, whatever you see over here. Now, which of the following are in liquid state? The sea, the rain, the cloud are in liquid state. Okay, I guess that the gaseous state cannot be seen. Okay, gaseous water vapor is invisible, therefore you can't say it's gaseous state. Or for the cloud is not gaseous state, it's more of a liquid state also. Okay, matter. What is matter? It means anything over there in the picture over here, right, has weight and occupies space. Right? Some of you are smart enough to say the sun is a matter because according to scientists, they found out that the sun is made up of burning gases, very heavy burning gases. Okay, and gas is matter, not the fire, but the matter itself that is burning. Okay, occupies space. Right. So these are the possible answers. Right. W and Z are two different plants. Study the plants carefully to answer questions. This plant is probably strong, has strong stem and this weak stem. That's why it's going down this way. And of course, the stem is growing nearer to the ground, and this is going upwards. All right. Now, how would this part T? They're referring to the stem. Part T supports the plant to get sunlight, and they help in transportation of water to all parts of the plants. Okay. Now, if you look very carefully, all right, there are two functions are stated here. First, it supports the plant to get sunlight. The stems will somehow, okay, direct and grow the plant in such a way to get sunlight. And they will help the second function, which you either state one of them will do, help in transportation of water to all parts of the plant. Now, the next, state one difference between the structure of plant T, okay, of part T in both plants. Okay, so part T, you must mention T for part T for plant W and also for plant Z. Describe them both, all right? So for W is strong and the part T is weak for plant Z. Okay, must be complete comparison. Now, based on the picture, which plant W or Z would likely not be uprooted if there's a strong wind? Okay, of course, you look here, the plant that is being very entrenched, right inside, okay, grown, rooted, deeply rooted, okay, will not be blown off this plant here as compared to this. Probably they are very near the surface, they can be blown off. All right, so plant W, it has deeper roots. Why? Explain your answer. It has deeper roots and that it holds the plant firmly, much more firmly into the ground than those of plant Z. Please make a comparison. Why it will not blown off easily? Because it is deeper and stronger, supports the plant than compared those from plant Z. Right, next. Compare these two animals, okay, what similarities? They lay eggs or they lay many eggs at the same time. How are they different in terms of their body covering? The snakes have scales and the frog is just basically covered with just skin, smooth skin, right? Let's carry on. Now these three creatures over here, two of them are obviously insect, the mosquito, the ants, the spider is not an insect. Now, which animal is not an insect? Explain your answer. Now, you must say C is not an insect. because it does not have the features of an insect. It does not have what an insect has. Okay, that means you cannot say, you can't say this way. This is not an insect because it has 8 legs. No, you must say this is not an insect because it does not have 3 body parts. Or C is not an insect because it does not have 6 legs. That is how you should answer. Alright, that's why it is not called an insect, because it doesn't have the features of the insect. Let's carry on. Now in B, the animals will regroup under the different category here. Can fly, cannot fly. So over here, A can fly. Make sure you see according to here. Okay, this one has wings, it can fly. These two cannot fly. So do not, okay, just put one will do. Okay, either B or C cannot fly. It's okay. You need not have to put B and C together. Just one will do, you see. You do not have to use all the options given. Right, 42. Take a look at these two, jar A and B. This one is sealed up. It means it has not enough air, right? The air may be here, but subsequently, later on, after a while, the air will be used up. So I will put here, air is not enough. There is no food given. There is water. Over here, air is given, no food, water is there. Okay, the water, they probably consume the water from the jar itself. Okay, now the fair test is the jar is the same, number of fish the same, and even the level, water level is the same. All right, the thing that is do not have for here is they both do not have food. So therefore, it is also a fair test. They do not have food. Okay, this has air and this has air. Okay, now take a look. After 3 days, all the fish in jar B died, and those in jar A survived. But later, much later, after 7 days or 1 week, all the fish in A died. It means in the end, both jars, the fish died. Right? This one 3 days, it died. This one is 7 days, then they died. Okay. Now, what was missing in jar B that had caused all the fish to die after 3 days? Over here, okay, missing is air. Okay, this has continuous supply of air, right, coming in from outside, okay, to the water for the fish. As compared both, this has limited amount of air. That is why it is not sufficient. That is why it leads jar B, fishes in jar B, to die first. Next, give one reason why the fish in jar A would not survive any longer. Now, jar A, they are given air and water. Now you must take note that living things need these three. Okay, air, food, and water. Air, food, and water. Okay, but only air and water was given. In the end, without food, okay, they will still die. But at least for jar A, they'll die later because only one factors, okay, or the food is taken away or lesser of food. But for jar B, both air and food are not there. That's why they die first. This one eventually they will die because there's no food. All right. So besides having air and water given, there was no food given to the fish. Eventually they die. State 2 common characteristic that all fish have. They breathe through gills. Very important. All fish will breathe through gills. They have fins or scales as the body covering. Okay? And what is very important is they live in water. All fish live in water. Alright? Probably the strongest point is they breathe through gills. They live in water, and they have some sort of body parts that allow them to move, help them to move in the water. Alright? carry on. Okay, for this system, the arrow is pointed to the large intestine, right? Which system this organ belongs to? The large intestine belongs to the digestive system. Okay, B, state the function of this. It absorbs water for the body. All right, that's all. Now this girl is playing soccer with her friend. She ran after the ball and kicked it. Ran means she moved, kicked it, right? Ball coming to her, she responded, she kicked it. Okay, what body structure enabled her to kick the ball? The skeletal system or muscular system. Okay, now when June ran fast, she breathed faster to take a few more breaths. All right, which organ from the circulatory system is working harder? The heart. Okay, the heart. Heart is an organ. Organs are part of a system. A few organs form together, work together to form a system. So the heart, okay, is one of the organs in the circulatory system. It pumps and works harder. Next, over here, take a look. Running, heartbeat 120, resting 70, less so. Walking faster a little, the heartbeat goes faster. Okay, so what is the relationship? Now this running is faster. Okay, this is fast, but this almost not much activity. So you say the faster the activity or the pace or the speed faster, for example, running, then the higher the number of heartbeat. That's the relationship. All right, something happens here, allows this thing to pump more than this. So what is this that happening here? More than this. Movement. Activities are more in running than resting, than just by mere walking fast. Okay, so the relationship is the faster you move, the more energy you move, or it requires you to move your body, the higher your heartbeat is. Okay, so got to do with the speed of the activity and the number of heartbeats, higher or lower. All right, that's the end. Hope you continue to enjoy your work and continue to learn from your corrections well. Thanks very much.